In this lesson, we're going to talk about variation, and there are four different types of variation that we're going to go through. So first off, let's just talk about what a variation problem is. So variation problems are equations that describe the relationship between two or more variables. There's always going to be just one term, so there's never going to be addition or subtraction in these problems. They involve using a constant of variation, and we use the letter k to represent that constant of variation. The four different types of variation that we'll go over is direct, joint, inverse, and combined. So first, let's look at direct variation. So the equation for direct variation is y equals kx, and k, remember, is that constant of variation. So what this means is as one variable increases, the other variable also increases. So if y increases, x increases. An example in real life is the more hours that you work, the more money that you make. So as your hours increase, your overall paycheck will also increase. So let's look at a simple example here. So if y varies directly as x, and y is equal to -3, and x is equal to 24, find y when x is equal to -16. So the first thing that we're going to do is we're going to write this as an equation. So when we translate this into an equation, we have y. And then when it says the word varies, every time that we see the word varies in any of these problems, varies is going to be equals k. So we always want to make sure that when we see varies, we put equals k. So y varies, so equals k, directly as x. So when it's directly, we know that it's being multiplied to the k, so we'll put the x here. So here is our basic equation. So now what we're going to do, first we have to figure out what the value of k is. So we're going to use the information they give us. So they tell us that y is equal to -3 when x is equal to 24. So we're going to plug that in, and we're going to say -3 equals k times our x value of 24. So we want to solve for that constant of variation. So when we do that, we get k is equal to -1/8. And that -1/8 is our constant of variation. So then what I like to do is just write our equation, the same equation that we wrote here, that y equals kx, but now we're going to plug in the k value. So y equals -1/8 x. So this is our generic equation for this problem. So now we're going to go ahead and solve the rest of the question. So find y when x is equal to -16. So now all I'm doing is plugging in -16 for x. So y is equal to -1/8 times -16. And we end up with y is equal to 2. So our answer is y is equal to 2. Another type of variation is joint variation, and that is the equation y equals kxz. And you could have different variables. You might not always have yxz. You could have abc, any combination of variables. It's similar to direct variation, where you're going to be multiplying by the constant, but in this case, you have multiple variables. So one variable is going to vary as the product of two or more other variables. So an example would be distance, rate, and time. So if your rate and time increase, then so does your distance. So everything is doing the same thing. They're all increasing. So let's look at this example. So suppose y varies jointly as x and z. Find y when x is equal to 4 and z is equal to -3 if y is equal to -15 when x equals -6 and z equals 1. So again, the first thing that we're going to do here is we're going to write our generic equation. So suppose that y, so here's y, varies, so that means equals k, and it's jointly as x and z. So jointly just means we're multiplying it to k. So we're going to have x and z now. So it's very similar to direct, just now that we have an extra variable. So we want to find y when x is equal to 4 and z is equal to -3 if this. So this is like our where we're starting. When we want to solve for k, we have to have all the other variables accounted for. The only variable that we're solving for now is the k. So we can't use this initial information here because they're only telling us x and z. We have to use the condition where they tell us all three. So y is going to be -15. K, we're going to leave as k. X is going to be -6. Z is going to be 1. So I'm going to get negative 15 equals negative 6k. And then I'm just going to divide by negative 6. So my k value here is going to equal 5/2. So my generic equation that I'm going to be using, again, I'm just going to take this one with the k in it and just replace the k with the 5/2. If you want to say 2.5, you can also do that. So y equals 5/2 xz. And that is the equation that we're using. So now we can go and solve the actual problem. So find y. So we're going to solve for y when we know the k is 5/2, x is 4, and z is negative 3. So if I multiply these together, I end up with y equals negative 30. Okay, the next type of variation is inverse variation, and that's the equation y equals k divided by x. So as one variable decreases, the other variable increases. So the two variables are doing opposite things. An example would be the more time you spend watching Netflix, the lower your grade will be. So if you spend more time watching Netflix, your hours of Netflix watching goes up, and your grade for whatever class will be lowered because you're not doing the work. Okay, so here's an example. If m varies inversely as n, and m is equal to negative 4 when n is equal to 6, find m when n equals 10. Okay, so again, first step, write your inverse variation equation. So in this case, we're using m. So m varies equals k inversely as n. So we're going to divide, by n. So similar to what we did before, we're going to use the information to solve for k. So m is negative 4, k over Rn, which is 6. So when we solve this, we get that k is equal to negative 24. We're going to take that, plug it in. So we'll say m equals negative 24 over n. So this is the equation for this problem that we're using. And then we actually want to solve for m. So find m when n equals negative 10. So we have negative 24 over negative 10. So m is going to equal 2.4. Okay, and the last type of variation is combined variation, and that's exactly kind of what it sounds like. You're combining the different variations together. So a basic equation would be y equals kx over z. So we have a direct variation, and we also have an inverse variation. So it's a relationship between three variables, could also be more than three variables, where one of the variables varies directly as one variable and inversely as another variable. So you can have multiple variables on the top, multiple variables in the bottom. Anything that says directly or jointly will always be with k in the numerator. Anything that says inversely will be in the denominator. So let's look at this example. Suppose a varies directly as b and a varies inversely as c. So let's just start with that. So a varies, so equals k, and it's directly as b, so b is going to get multiplied to k, and inversely as c, so c is going to be in the denominator. Okay, so then we want to find b when a is 6 and c is 28 if this. So we want to make sure that we use the correct information first. So remember, we're looking for where it tells us all of the variables because we need to solve for k. So a is going to be negative 49. K is what we're going to solve for. B is 7. And then c is 3. So if I go ahead and solve this, I'm going to get, well, I'll multiply by 3 first. So I have negative 147 equals 7k. And if I divide by 7, I'm going to get that k is equal to negative 21. So when I plug this in, I'll say a is equal to negative 21 b over c. So this is my equation that I'm using because I've plugged my k value in. And then now we're going to solve for b. So solve for b. So when a is 6, so we're going to plug 6 in for a. We have negative 21 as our k. B is what we're solving for, so we'll leave that as b. And then c is 28. So we're going to multiply both sides by 28. So we'll get 168 equals negative 21b, and then divide by negative 21. So our b is going to be negative 8. All right, so we're going to do one more combined variation example. So y varies jointly as x and z and inversely as w. So let's write that first. So y varies, so equals k. It's jointly as x and z. So jointly, remember, is just being multiplied to k. So we're going to have x and z up here with k. Inversely as w, so w is going to go on the bottom. Okay, so they're telling us that y is equal to 3/2, and k is what we're trying to solve for. X is 2, z is 3, and w is 4. So if I multiply both sides by 4, I'll get 6 equals 6k. So k is equal to 1. So when I go to plug this in, my equation will be y equals. Since k is 1, I don't necessarily need to show a 1 since it's going to be understood. So I'm just going to write this as xz over w. This is my equation that I'm using. Oops. And then we're going to go ahead and solve for y. So find y when x is 5, z is 1, and w is 7. So y is going to equal 5 over 7. Okay. And now we're just going to look at a couple of word problems. Okay, so here's our first one. The number of buckets of paint N needed to paint a fence varies directly with the total area A of the fence and inversely with the amount of paint P in a bucket. So let's first just set this up. So the number of buckets of paint, so that's going to be N, and it says that it varies, so equals K, and then it says directly with the area, so we're going to multiply A, and inversely with the amount of paint, so over P. So this is going to be our equation that we start with. And then it's going to tell us our information so we can solve for K. It says it takes 3 1-gallon buckets of paint to paint 72 square feet of fence. So if it takes 3 1-gallon buckets, N is the number of buckets. So that's going to be 3. K is what we're going to solve for. The area is 72. And P is the amount of paint in the bucket, and it's a 1-gallon bucket, so it's going to be 1. So now when I go ahead and I solve this, I'm going to end up with K is going to equal 0.042, okay, or 1 over 24. So I'll plug that in. So N equals 0.042 A over P. So this is going to be the equation that we use. And then we're going to find the answer that they're asking for. So how many 1-gallon buckets? So we're trying to solve for N. So we have N equals 0.042 needed to paint 90 square feet of fence. So the area is going to be 90. And again, the amount of paint in the bucket is going to be 1. So N, if I solve this, is going to equal 3.75. So how many buckets of paint do we need? We'll round this up and we'll say N equals 4 buckets. Because it's a word problem, we want to make sure that we are labeling our answer with the units. Okay, and we are going to round up here because you can't have 0.75 of a bucket. We're going to need a 4th bucket. Okay, and we'll look at one more example. So the earned run average, or ERA, and we're going to use the variable A for that, of a baseball pitcher varies directly as the number of earned runs are, and inversely as the number of pitched innings P. So let's write that equation. So the earned run average, and we're going to call that A, it says that that varies. So remember, varies is equals K, directly as the number of earned runs are. So we're going to multiply the R to the K, and inversely as the number of pitched innings P. So we're going to divide by P. So here's our basic equation. Okay, now what we're going to do is plug in the information they tell us next. So in one season, a pitcher has an ERA of 2.475 equals K. 80 innings are pitched and 22 earned runs. So 22 is our R, pitched, which is our P, is going to be 80. So we're going to multiply, and we're going to get 198 equals 22K. Divide by 22, so K is going to equal 9. So again, I'll write my equation I'm using. So A equals 9R over P. Okay, so now we'll solve what they want us to solve for. So find the number of earned runs. So we're trying to find R. If the pitchers has an ERA of 2.25, so 2.25 is A, equals the 9. We're trying to find the R, so we'll leave R as R, and they're pitching 112 innings, so 112. So we're going to multiply both sides by 112, so we'll get 252 equals 9R, and then divide both sides by 9, so R is going to equal 28, and that's 28 earned runs. And again, make sure that we label it with the proper units. Okay, so for homework, you guys are going to try these 4 problems. Make sure that you write your basic equation for the variation first, solve for K, and then plug everything in to solve for the variable that they ask for.